All right, let's get right into it. For years, the most powerful AI models have kind of felt like a magic show, right? We see these absolutely amazing results, but the methods behind them? Total trade secret. Well, today, we're looking at a new model that doesn't just perform the magic, it shows us exactly how the trick is done.
So check this out. This is one of those real-world puzzles that would make most of us pull our hair out. But a new AI model, Molmo, just looks at this ridiculously confusing sign and spits out a perfect, clear answer. It gets the dates, the times, all the exceptions. Pretty impressive, huh?
And while its abilities are honestly incredible, that's not even the real story here. The true breakthrough isn't just that it's a state-of-the-art model, it's that we finally know how it was made. For the first time with an AI this powerful, the researchers have opened up the entire cookbook. And trust me, that changes everything.
To really get why this is such a big deal, we've got to talk about a huge issue that's been hanging over the world of AI research, what we call the black box problem.
So here's the deal. The best of the best, the models that can see and understand the world, think GPT-4o or Gemini, they're all proprietary. They're locked up inside big companies, and their architecture, their training data, their code, it's all top secret.
And this has basically created two different classes of AI. You've got the closed proprietary models on one side, and on the other you have these so-called open models. But a lot of these open models have a bit of a dirty secret. They're often trained on data that was created by the closed ones.
It's a process called distillation. So imagine trying to bake a world-class cake just by tasting a slice. You might get pretty close, but you'll never really understand the chef's technique or the quality of their ingredients, right? That's what distillation is like in AI. It stops the scientific community from actually learning how to build these incredible models from scratch.
And don't just take my word for it. The researchers behind Molmo said it themselves. The community is missing the fundamental knowledge of how to build these things from the ground up. We're just getting copies, not a real foundational understanding.
But that is exactly the problem this new research blows wide open. So let's meet the heroes of our story, Molmo, and its amazing partner, PixMo. So Molmo stands for Multimodal Open Language Model. It's a brand new, top-of-the-line AI that understands both images and text. And PixMo? That's the rocket fuel. It's a massive, completely new collection of open data sets, all meticulously put together by humans with zero data from any other proprietary AIs.
So how'd they do it? How did they build a model that could go head-to-head with the giants without just copying their homework? Well, the answer comes down to data. But not just more data, much, much better data.
To get this amazing data, the researchers used a super clever trick called modality switching. Instead of asking people to type out long descriptions of an image, which, let's be honest, is a drag and usually gives you short answers, they just had them talk. People would just describe an image out loud for about a minute or so, then that speech got transcribed and polished into a really detailed caption.
And the results? Wow, they really speak for themselves. The average caption in their PixMo dataset is almost 200 words long. That is 5 times longer than the next best dataset and nearly 20 times longer than a classic one like Coco. I mean, this method just produced incredibly rich, detailed, human-generated data.
But get this, they didn't even stop there. They brought in another cool innovation, pointing data. So now, instead of just describing what's in an image, the model can actually point to it. You can literally ask it to find Mount Rainier, and boom, it'll drop a marker right on the peak.
This pointing ability, it's a total game changer. It makes counting stuff way more accurate because the model can point to each thing as it counts. It can visually show you why it gave you an answer. And just think, in the future, AI agents could use this to interact with websites, or even robots could interact with the real world just by pointing. The possibilities are huge.
Okay, so the theory is awesome. The data is truly innovative and open. But what about the main event? How does Molmo actually perform when you put it in the ring with the closed-source giants like Google and OpenAI?
Let's just look at the scoreboard. On a whole bunch of academic benchmarks, the biggest Molmo model scores an 81.2, beating both Gemini 1.5 Pro and even the mighty GPT-4o. And in human evaluations, where real people rank which answer they like best, it comes in second place, just barely behind GPT-4o.
Second place. Let that sink in for a second. This is a fully open model built from the ground up with completely open data, and it achieved the #2 spot in the entire world in human preference tests. That is a massive, massive win for the open source community.
Now, this top-tier performance isn't just about the data. The team also made some really smart design choices. For example, when the model looks at a high-res image, it breaks it into smaller pieces, or crops. But here's the clever part. Instead of just laying them side by side, they overlap the crops just a little bit. And that simple little trick makes a huge difference. As you can see with the brand name on the bike, that overlap makes sure the model never loses context when it moves from one crop to the next. It helps Molmo literally see the bigger picture. So it's this awesome combination of better data and smarter engineering.
And all this brings us to what might be the most important takeaway from this whole project: what this means for the future of how AI gets built.
See, the team isn't just releasing a model and calling it a day. No, they are releasing everything. The model weights, all the new PixMo datasets, the source code you need to train it, and even the tools to evaluate it, the whole shebang. This is so much more than just a single breakthrough. It's a complete blueprint. It's an open-source recipe that any researcher, any university, or any company can now use to build their own world-class vision AI without having to rely on any secret, proprietary data. It's democratizing knowledge that used to be locked away.
For years, the big question has been, can the open-source community ever really catch up to the proprietary giants? Well, I think this research proves the answer is a resounding yes. And it leaves us with an even more exciting question. Now that the blueprint is finally open for everyone, what are we all going to build next?